All right, so picking back up on these logarithms. So just to recap really quick, just remember, so a logarithm is a fancy way of writing an exponent, right? So if I have log base argument x equals y, this is the same as saying b to the y power equals x. All right, so if I'm trying to solve for x, right, I need to figure out, well, what's this value of x? What's the argument of this log? Well, I'm going to rewrite it. I'm going to rewrite it in the form of an exponent like so. So I'm basically going to say my base is 16 to the 3/4 power equals x. All right, so now, again, this is going back to chapter 13, right? So I have this exponential equate or function with a rational equation, right? So how do I write exponential equations in radical form, right? So remember, when we have a to the m divided by n, this is like saying exponentially the nth root of a raised to the m, right? So I'm just going to say, okay, well, this is the fourth root of 16, and really I should have put this on the outside, raised to the power of 3, right? So you got, you evaluate, this is a grouping symbol. So PEMDAS tells us to evaluate this first. That's why I said I shouldn't have wrote it like this, before we raise this power of 16 to the third power. So don't go and look at this and say, oh, I'm gonna raise 16 to the third power and then take the fourth root of that, because sometimes it coincidentally may be right sometimes when you have the right numbers in place, but that's just not the process, right? So PEMDAS tells us to do our grouping symbols first. P parentheses is our grouping symbols, not just parentheses, right? So the fourth root of 16, so x to the fourth equals 16. Like, what to the fourth power is 16? Well, that's 2, right? And now we just take our 2 and raise it to the third. 2 times 2 times 2 is 8. Therefore, x equals 8, right? And then this would be our solution. So 16 to the 3/4 power equals x, right? And then, like always, we can check this on our calculator. We can say 16 raised to the, I'm gonna just say 0.75, right? Just so you guys can see all of this. When you're doing math, like when you understand it, you manipulate it however you want to manipulate it to make it fit. Now, if this was to the 1/3 power, I wouldn't have put 0.33 because that's not terminating. I would have been rounding. Even though 0.75 is rounding, it still terminates, right? So on my other calculator, let me see if I can still figure this log out. I can go ahead and plug it in. I can say, actually I can't because I'm looking for x. So I was about to say, but if I said 16 and I'm saying the solution is 8, right? It should now spit out 3/4, which is 0.75, which on this calculator, to change it to a fraction, I don't see the key, and I don't feel like playing with, yeah, I don't see the fraction key, but we hopefully we know that 0.75 is just 3/4. Oh, here it is. So change that to a fraction. There it is, 3/4. All right. So hopefully, as we're looking at this, like, oh, okay, that's making sense. I just got to put it into something in which I can evaluate. All right. So looking at this next example, log base 4 argument 8 equals x. So I'm gonna just rewrite this, right? So I'm gonna say 4 to the x equals 8, right? And again, there's a few ways we can do this. We can always say the log of 8 divided by the log of 4 equals x, right? That's one way of writing this, because this is basically log base 10 of 4 to raised to the x equals log base 10 of 8, right? And I'm solving for x, so I just isolate. Or I can say, well, I can't get 8 to a base of 4 and raise that to a power and still get 8, right? At least I don't, not with whole numbers, right? But I can manipulate my 4 to a power of 2 and still get 4, and I can manipulate my 8 to a power of 2 and still get 8, right? So 2 to the what power is 4? So I can say, well, 2 to the second times x is still the same as this, right? And that equals 2 to the third, right? And so now when my bases are the same, I can cancel the bases, and now I just need to solve for x. 2x equals 3, so 2x equals 3. Divide both sides by 2, and so now my solution is 3/2, right? And so it's just all about manipulating, right? So if I went to my graphing calculator, and let's just say from here I wanted to solve it, right? From there, well, I would say log base 8 or log base 10 argument 8 divided by log base 10 argument 4. That gives me 1/2, which if I change that to a fraction, I get 3/2. All right. Now, what happens if you're given this an exponential equation and you're asked to write it as a logarithm? Let's say if you had 4 to the 5th power equals 1024. Right? First off, let me make sure my math. 4 to the 5th okay, so 1024. And you were asked to write this logarithmic, like write this in logarithmic form, right? So you would say log of my base. Well, what's my base? Well, my base is 4. So I'm going to say log 4. Now I need to figure out, well, what's my argument? My argument is what the exponent equals. Log 4 of 1024 equals the exponent, right? Which is 5. So I've taken it from exponential form and I've written it in logarithmic form. Or I can go from log form and write it exponentially. Alright, so remember, logarithms, it's just a fancy way of writing exponents. Okay, there are a couple of properties that we need to follow from time to time. Alright, but don't let this chapter intimidate you. Talk to you soon.